Problem number 60. A 4 kilogram bundle starts up a 30-degree incline with 150 joules of kinetic energy. How far will it slide up the incline if the coefficient of kinetic friction between the bundle and the incline is 0.36? Let's see the figure related to this question. So what we have in this figure, we have an inclined plane and its angle is 30 degree. So we have a bundle in this location, that is our initial position of the bundle, and this bundle starts moving up the incline and it reaches the maximum height. So when this bundle reaches the maximum height, how much distance it's covered, that value we have to find. And also they mentioned there is a friction between the bundle and the incline, so they gave the kinetic coefficient friction value, which is 0.36, that is nothing but mu k value. So the mass of the bundle, which is 4 kilogram, and the theta of the incline is 30 degree. Initial kinetic energy is 150 joules, and then the kinetic coefficient, that means which is mu k, 0.36. So these are all the informations they gave. What we have to find? We have to find the answer for the distance covered, that is d value. Now the most important thing here, we have to use the rule work done, which is equal to change in thermal energy plus change in mechanical energy. So mechanical energy is the combination of potential energy plus kinetic energy. So we have to write this rule as W, which is equal to change in thermal energy plus change in kinetic energy plus change in potential energy. If the system is isolated, then we have to consider work done, which is equal to 0. So when you equate this equation to 0, the equation will become change in thermal energy plus change in kinetic energy plus change in potential energy, which is equal to 0. As we know the formula for thermal energy, we know the formula for kinetic energy, we know the formula for potential energy, so it will be easy to solve this question. And also in the initial point, the initial kinetic energy they mentioned 150, that means Ki value, which is 150 joules. When the bundle reaches the maximum, there is no speed, so your final kinetic energy will be equal to 0, because half mvf square, if vf will be equal to 0, your kinetic energy final will be equal to 0. Clear? Now we have to substitute the value very carefully. So now what we have to do, either you can find the answer separately one by one, and then when you solve, by that also you can get the answer, or you can substitute the value directly. Clear? Okay. Now let's see. I'm going to write the formula for thermal energy. So what is the formula? What is the value for thermal? Or we can write the formula Fk multiplied by d plus kinetic energy final minus kinetic energy initial plus potential energy final minus potential energy initial, which is equal to 0. Clear? Now what is Fk? Fk is nothing but mu k Fn multiplied by d. And what is Fn? Fn, you have to draw the free body diagram. As we know, if this is Fn, this will be force due to gravity mg. So this is mg cosine theta, and this will be mg sine theta. Mg sine theta. So your Fn, which is equal to mg cosine theta. So in place of Fn, I can write mu k mg cosine theta multiplied by d. Clear? Plus your kinetic energy final, which is equal to 0, right? So we no need to write this because already we got the answer for this thermal energy. So I can delete this one. So we can come here. So what is your kinetic energy final, which is 0? What is the initial kinetic energy? 150 joules. And then for potential energy, you should be very careful. Your potential energy, this is the initial point and the final point. So for the initial, there is no height. So what will happen? Your initial potential energy becomes 0. So what is remaining? Only you have final potential energy, which is equal to 0. Clear? Now what I'm going to do, I'm going to take this term to the right hand side. By that, what you'll get mu k mg cosine theta multiplied by d plus your formula for potential energy is nothing but mg h final. So when you take this minus 150 to the right hand side, it becomes plus 150. So I can write like this. Now we have to find what is the value of hf. So we have to go back to the figure. So what is hf? So this is your hf, right? So for that, we have to use the formula for sine theta, which is nothing but opposite side by hypotenuse. And your opposite side is hf, your hypotenuse is d. So you will get sine theta, which is equal to hf divided by d. Therefore, hf, which is equal to d sine theta. So what I have to do, I have to take this hf, I have to substitute here. By that, this equation becomes mu k mg cosine theta multiplied by d plus mg d sine theta, which is equal to 150. Now we can take the common term outside, and also we are going to find the value of d. So we can take mgd outside. So if you take mgd as a common term outside, what is inside? Mu k cosine theta plus sine theta, which is equal to 150. So mgd, which is equal to 150, because these are all multiplication. So we can take this entire term to the denominator of the right hand side. So by that, this becomes mu k cosine theta plus sine theta, because we are going to find the d. So therefore d, which is equal to 150 divided by mg, also we can take here. So mg multiplied by mu k cosine theta plus sine theta. Now what I'm going to do, I'm going to substitute the value. So if you substitute the value, you'll get the answer for the final. So therefore d, which is equal to 150 divided by the mass of this object is 4 kilogram, g value is 9.8, and mu k value is 0.36, multiplied by cosine of, what's the angle? The angle value, I have to see what is given in the angle. Angle is 30 degree, right? So 30 degree. So cosine of 30 degree plus sine of 30 degree. So the answer here is 150 divided by 4 multiplied by 9.8 multiplied by 0.36 multiplied with cosine of 30 degree plus sine of 30 degree. So we have to close the bracket. So the answer I got here as d, which is equal to 4.71 meter. So this is the answer for this question. That's it. Thank you.